Hello, my name is Isabel Morales, and today I will be walking you through a projectile motion problem. A professional football player throws a football at 45 degrees above the horizontal with a speed of 55 miles per hour. Find the maximum height the ball reaches in meters if the football player is 1.88 meters tall. Given the situation, I think it's best if we start off with a diagram first. The y component of our velocity is going to equal 0, as at this point, at its highest point, the only velocity that the ball experiences is in the x direction. So our y naught would be signified by the football player's height. Y final is 0 meters, our x naught, which we can assume to be 0, and our v initial is 55 miles per hour, which if we convert to meters per second using dimensional analysis, we get 24.6 meters per second. We can now start thinking about the kinematic equations of which are at our disposal. Since we know Vy at its maximum height is equal to 0, and we can calculate the initial Vy naught, I suggest in order to find the time at which the ball is at its greatest height, we use this kinematic equation. V final is equal to V naught y minus gravity times time. In order to find our V naught y, we multiply V initial times the sine of 45 degrees. And this is to find the y component of our V initial. If we were to rearrange this equation, it'd be, and if we were to plug this in, we would have a t of 1.77 seconds. Now that we have the time at which the ball is at its highest point in its path, we can now use this kinematic equation. And so our y initial is the football player's height plus our y naught times rt, 1.77 seconds, minus 1/2 times 9.81 meters per second squared times rt again squared. We get a height of approximately 17 meters.